The first paper for this session is Impact of Hydraulic Loading Rate on Performance of Constructed Wetlands for Wastewater Treatment. Now, this paper is prepared by Mr. GMPR Weerakoon, KBSN Jinadas, GBB Herath, and MIM Mowjood. It will be presented by GMPR Weerakoon. If I may give a brief introduction about Mr. Weerakoon. Mrs. Weerakoon. Graduated from the University of Peradeniya with BSc Engineering in Civil Engineering and obtained her MSc in Environmental Engineering from University of Newcastle upon Tyne, UK. Currently, Mrs. Weerakoon is reading for PhD degree in University of Peradeniya. She is a lecturer at the Department of Civil Engineering, Faculty of Engineering, University of Peradeniya. Her research interests include low-cost and sustainable wastewater treatment mechanism. May I now invite Mrs. Weerakoon to present her paper. I'm sorry about the mistake I made at the beginning.
Thank you very much, and good afternoon to you all. Today, my presentation is about impact of hydraulic loading rate on performance of constructed wetlands for wastewater treatment. And I am Prabha Weerakoon, and these are my colleagues or co-authors of this paper. So, as we all know, the generation of wastewater has been increased enormously during past few decades with population growth and associated urbanization, industrialization, agricultural interventions, and also the lifestyle changes. Now, if we discharge these wastewaters into natural environment without proper treatment, it will create public health hazards because it is a very easy pathway for waterborne disease transmission. And it will create socio-economic conflicts, and it will be an aesthetically very unpleasant sight. And on top of that, it will damage the environment, and the whole biodiversity will be affected. Therefore, ultimately, it declines the beneficial use of freshwater resources for humankind. Therefore, we need to treat these wastewaters properly before discharge them into the natural environment. And as a hub in Asia, the way forward has to take an immense attention for discharging these wastewaters into the environment to provide a clean environment for everybody. So if you see, there are many conventional wastewater treatment techniques, but the problem is they are not used, or their use is limited in developing countries due to financial and managerial constraints. And therefore, sometimes as a firewood. And in addition, performance of these constructed wetlands are expected to be high in tropical countries like ours, as the temperatures are high. And however, the main disadvantage of these wetlands are the higher land area requirement. So if we see the key features of constructed wetlands, so it should have definite inlet zone and outlet zone for even distribution of wastewaters and collecting of them, and it should have bed media for interaction of pollutant removal, and wetland plants. It can be rooted, immersed, submerged or floating plants, and there should be a subsurface barrier to prevent wastewater leaching into the soil, and a water column and microorganisms. All these will be interact together to improve the water quality. And if we see the types of constructed wetlands, basically we have two types according to the water column. As subsurface flow constructed wetlands, when the water is flowing above the substrate media, and that is surface flow constructed wetlands, when the water flows above the media, and we have subsurface flow constructed wetlands. And according to the flow direction, we can divide them as horizontal subsurface flow constructed wetlands when the flow is flowing horizontally, and then we have vertical subsurface flow constructed wetlands when the flow flowing vertically downwards. And combination of all these types are also available and known as hybrid constructed wetlands, in that weaknesses of each other can be compromised. And also we have floating wetlands. If we have a large water body, we can get use of them to treat that water like this. And in this study, we have combined horizontal subsurface, we have studied horizontal subsurface flow and vertical subsurface flow constructed wetlands. And with that, our objectives were to examine the impact of hydraulic loading rate variation on treatment performance in subsurface flow constructed wetland systems in order to reduce the land area requirement, and to select the most favorable hydraulic loading rate at varying hydraulic conditions. And this is our experiment setup. We had 4 wetland units with 1.4 meters, 0.5 meters and 0.6 meters in size, and planted with Typha angustifolia, and substrate we used is 10 to 20 millimeter size gravel. And we had 2 horizontal subsurface flow systems and 2 vertical subsurface flow systems. And this is a schematic diagram of a horizontal system, and this is a schematic diagram of a vertical flow system. This is how we have constructed them, and this is a full-grown wetland system. And the wastewater, what we used here was synthetic wastewater. We dissolved all these things in the tap water and prepared the synthetic wastewater, and then we have applied them into the wetland units, and actually we have varied the hydraulic loading rate according to this sequence shown here. We have increased the loading rate in 12 days intervals, and we have collected samples at the end of each 12-day period, and from influence and effluence of each wetland unit, and then analyzed for BOD, total suspended solids fecal. Shows the removal efficiency in the vertical subsurface flow system, and the green line is for horizontal subsurface flow system, and we can see there is a slightly better removal in vertical subsurface flow system. However, the efficiency is slightly decreased with the increasing hydraulic loading rate. And when we see the total suspended solid removal efficiency, that also up to about 20 hydraulic loading rate, it was slightly decreased, but then it was drastically decreased since then. And when we see the fecal coliform removal efficiency, we can see up to 25 centimeters per day hydraulic loading rate. The removal efficiency is more or less about or more than 96%, and then after that it was drastically reduced. Similarly, total coliform removal also act accordingly. And then this is the plant growth measurements, and from this graph we can see the horizontal plant height in the horizontal subsurface flow system is slightly higher than the vertical flow system. And if we see the shoot density, we can see that in the vertical flow system there is a higher root density in the middle of the study, and there that may be the reason for slightly higher removal in vertical subsurface flow system. And with that, our conclusions were vertical subsurface flow wetland system performs slightly better than the horizontal subsurface flow system, even though there are no much significant treatment difference between them. And both systems were able to remove pollutants substantially up to 25 centimeters per day hydraulic loading rate. However, this 25 centimeters per day hydraulic loading rate needs further clarification before making a firm decision. Thank you.